Perhaps one may have heard of the term or terminology superheat in the heating and air conditioning HVAC industry, and one may wonder what the term means, how it functions, what it does, etc. So if we take the old gauges, perhaps it may be a good idea to learn this on the old gauges. The new digital gauges may calculate this for you, so they make it a lot easier and a lot simpler. But sometimes if one uses the older manifold gauges, so to speak, it may add or lean to the comprehensive understanding of how superheat, subcooling, etc. works. So superheat perhaps may be done on the blue side. You have the blue, the low pressure side, the red, the high pressure side. So once the gauges are hooked up and in gauges, etc., each refrigerant has a particular, maybe a different color. The jug may be a different color and kind of color coded, which makes it easier for an individual to understand. So here we read that the 410A is the yellow, R22 is the green. So if we take this up in the green and we connect this onto the system, and the system have the system running, say if we measure 100 psig, and then we go over here, and this is, as we can see, this says degrees Fahrenheit. So if we go 100 and go over here, and it corresponds to, I think, 60, so this would be 60 degrees. At 100 psig, pounds per square inch gauge, I think that perhaps may say, if we go over here, it reads 60. So then we keep that 60 or write that 60 down in a number. If we're doing it with, I think, a capillary tube, it may be a little bit different if the system has a TXV, a thermostatic expansion valve. But anyway, that I'm not sure of. The experts, HVAC experts, can elaborate. So then what I've done, and many other people, I'm not an original here, but there's many other people, just the superheat calculation is you have your gauges on the line set outside. You have one bigger copper line, one smaller copper line. This would be the larger copper line. So superheat equals the line temperature minus the gauge temperature. So say we go back over here, and I think if we were reading 100 psig and we reference this to 60, so in this, say the line temperature, the temperature of the line outside was say 70 degrees hypothetically. So we would say 70 minus 60, or just say the line temperature was 75 degrees, hypothetically. The line temperature outside, where we have the clamp, the temperature clamp on the line, now we know the line temperature according to the meter, and then so 75. We have a gauge temperature of 60, which we referenced from the 100 to the 60. So we would take 75 minus 60. So that would be, the difference between that would be your superheat. So this would tell you basically at what your superheat is, and this is where the boiling temperature and the temperature perhaps inside of the A coil. So about a 15 degree superheat would be perhaps optimal. So subcooling maybe 10 to 12, somewhere in there, I'm not certain. But so this is just a simple way to do it with the manifold gauges. If you understand how to do it with the manifold gauges, then at this point, when you or one uses the digital gauges may give you the calculation, which makes it so much easier. But if you don't understand it, it can be difficult. So do keep in mind, and also keep in mind that refrigerants, water may boil at 212 degrees Fahrenheit, somewhere thereabouts. I'm not certain what that is. One that knows can add that to the comments. However, keep in mind some of these refrigerants can boil at at minus like 40 degrees or somewhere plus or minus in there. So just the boiling temperature of everything may not be the same. And then there's certain variables that factor in. But anyway, a quick way to calculate superheat here. Just say take 100 psig, and we're using R22, so this is going to be the green as we see this. So we come here, 60. We have our temperature clamp on the hose, and the temperature clamp says 75 hypothetically, so we say 75 minus the gauge temperature is 60, so our superheat would be 75, somewhere around 15 degrees, I think. So my math is in my brain is limited with numbers. So anyway, this is how it's done. It's very simple. And then again, to reiterate, if you get the digital gauges may calculate it for you and make it easier. But it's good to understand the theoretical behind it, and then it makes it easier when for just future use, future diagnostics, and just a peace of mind. Thank you for watching. Have a great day.